Welcome to the Cosmic Obsession live broadcast feed on the Night Skies Network. Right now, if you're watching the video on YouTube of M17, you're looking at a wonderful nebula called the Omega Nebula. Joining us tonight on the Night Skies Network are 20 of our closest friends and amateur astronomers and viewers and listeners and friends, and Bob and myself. My name's Francis, and our wonderful lady friend Debbie are all here, amateur astronomers, bringing to you a live broadcast on the Night Skies Network of the Cosmic Obsession Observatory. The Cosmic Obsession Observatory is located in Tomball, Texas, but you can see our live feeds from anywhere around the world. Right now you're looking at M17, a delightful object embedded in the glowing mist of the Milky Way. M17 is named for its resemblance to the Greek letter omega. Under clear and dark skies, M17 can just be seen with the naked eye. In binoculars, the nebula takes on an elongated shape. A loose cluster of 30-plus members is dispersed throughout the nebula, but is not as evident as the one within nearby M16. Star formation is likely still taking place in this nebula. Close observation will reveal a great amount of detail, including the nebula's swan-shaped cloud of nebulosity. Can you see the swan? M31, is that a question, M31?
You might want to go to M31, but our focal reduction probably won't let us do 30.
Our focal reduction might not let us do M31, Jack. This picture of M17 is quite fabulous, though. And seeing it, I mean, it is really an awesome image right there. I do see the swan. Right? Do I see the swan? Do you see the what swan? What am I looking for? Swan. Oh, here it is, right there. There's the beak, right there. There's the beak. There, its head. There's the swan. Do you see? I see the swan now. You have to tip your head to the right a little bit, 40 degrees, 45 degrees, and look at it again. There's a very dark area right there, above top center. That would be its black beak. And then its head would curve around, comma shape, and then its body is that bright spot. I sure do see a swan. Can we see M31 again, he's asking. Jack, we're not sure if our setup for tonight's live broadcast will allow us to see M31. We will look at where it is in the night sky. We are looking at a particular area of the night sky. If M31 is maybe on the other side of the meridian, we may not get there. But I can tell you right now that Bob, the controller, the astronomer, controller of the telescope, is looking right now for you on M31. We're going to see what we can do. Oh, Sylvan, thank you very much for joining us. I do appreciate it. Nope, no M31. M31 will reappear in our local sky when it rises tonight at 11:41 p.m. and will look best tomorrow morning at 7:53 a.m. It is currently 7 degrees below the horizon. Choose whether to the horizon before considering it or reset the time. So, M31 is not currently visible from our location here in Tomball, Texas. It will rise above the horizon sometime after 11 p.m. and it won't be in its best position for viewing until 7:30 a.m. You're welcome, Jack. Thank you, Sylvan. Thank you for joining us. We'll talk to you soon. We always enjoy your presence here at the live broadcast of Cosmic Obsession Observatory, as we do with all our friends. I know that for some of my friends, my name's Francis. You haven't heard me on the radio or on the air for a while, so I was happy to come over after work and do this broadcast for you to hear my voice. And we're taking the live screen captures and we're going to post them up on YouTube so that anyone who didn't make it or didn't recognize what was going on can see them tomorrow.
We're going to take a run down to M20, the Trifid.
We're going to go down to the Trifid Nebula, M20. Here comes M20, the Trifid Nebula.
MFR5 is what we have in it.
Right now there's the MFR5 focal reducer in this, which actually, like, if you're looking at the horse head, it really blows it up. You don't get to see much of the whole horse head.
Actually, the aperture of the scope makes it too big, and we try to focal reduce it down to get the image to the right size and all. So we're actually reducing the image with MFR5, which is, I think, is only 0.75%.
All right, 0.75%. We're going to, where are we going? The M20? M20. M20. The Trifid Nebula gets its name from the rifts of dark matter that trisect its southern region. The Trifid lies in a rich area of the Milky Way, with M21 and M8 visible in the same binocular field of view. This trio makes a stunning sight and is best seen at low power. M20 and M8 may be physically connected, although this is uncertain. The Trifid Nebula is a hot red emissions nebula of hydrogen gas surrounded by a blue reflection nebula made up of dust grains. Hachu. I'm going to keep recording this screen capture as we move to the Trifid to M20. So if you're watching this on YouTube, stay tuned. We're going to get to M20 momentarily. If you're watching this live with us, you can see the action occurring live on your screens as we see it at the same time. This is the Sync Star.
This is the sync star, that's right. It's actually a star that it syncs to this near the object here. To make real accurate tracking,
They use a star to sync on rather than the actual object. We're going to get the guider started and do some exposure. Integration, I mean. Integration equals exposure.
That's correct. Okay, guide star is started. Same amount of integration.
What, 45 seconds? 36? We're on 36 second integration, so we're going to wait 33, 32, 31, 30, 29, 25, 20, 15. Hello, Stu. 10. 2, 1, 0. Ooh, man. Well, come on. Here comes. Woo! Golly, Bob. I haven't seen these before.
I can't believe you had them.
I haven't seen all this before. Golly. It looks like a heart valve. Right? That's how a heart valve. That's how these heart valves. They're little triangle heart valves. That's what it looks like. It looks like a heart valve. Because that's what they're like. Heart valves are like three little openings. Bloop, 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 bloop. I've never seen that M20 before. Was it there yesterday?
Yes, sir. If it wasn't, we got to speak.
Oh, really Aussie amateur. We're here to have a good time. Here to lightly interpret deep space. You have it. That's a great picture. I'm recording it. That's
Well,
right.
leave it alone then.
Yeah, don't mess. Don't make it terrible because we're still recording. See, that's good though. Look at here though. See, like this right here.
Yeah,
That's like real. That's really nice. We need to start doing our registacks. We need to get our registacks registracking.
yeah, but we can clean these up. I think we put too much background in it.
All right. But it lightens it up a little bit. Oh, see, that's nice right there. You're getting it.
I need to, and I hate to kill the program. I need to change my AGCs a little high. Is we're gonna get so much graininess in the background.
All right, we'll change it up.
If everyone wants to bear with me for 3 minutes,
We're gonna do it.
After this object here.
Yeah, after this object, we're going to go to a 3-minute countdown and get it so our AGC adjusted on the camera.
Which is creating some graininess in our background. So.
I believe you're seeing the same thing, Aussie. I don't see how you're seeing anything else. I've never seen it before. I like it.
I can't believe that. You know, but all these objects, I mean, the springtime is for globulars, and then you start getting into the nebulas, and they go, you know, it just comes different times of year for all of
It's
us.
like yours over there with it smaller. That's a beautiful picture over there.
Well, typically when they're smaller, you get a tighter, more resolution. So. Which one? Orion? What's he spelling?
Can we see the what?
Probably Orion, I bet.
Oh no, we can't see it. We can't see Orion. No.
Wrong time of the year. It's
Wrong time of
below the
year.
horizon.
It's below the horizon. Now it's with the sun. The sun owns it. Yeah, Orion is a banned word. You can't say it. You can't say it. Can't say it.
It's a proprietary thing, which I'm sure we're getting within NSM.
Saturn. We are actually, the camera and the telescope is set up for deep space objects. Saturn isn't considered a deep space object.
You're right, Stu. In a couple, 3 months, it'll be ready to go again.
Pluto. Pluto is an extremely hard object to find, and in fact you would need a series of still shots to determine that what you're looking at is Pluto by the fact that it would be moving against the backdrop of stars. It would take approximately 40 minutes of imaging Pluto to figure out where Pluto was. Ooh.
Plus, we have to get the big scope out to see it.
I imaged Pluto in April of this year. I can show you the video. I can link the video. Oh, but I'm recording. I'm going to go ahead and end this video.